Hey everyone, thanks for tuning into my presentation about Pacific Golden Chanterelle mushrooms in Tillamook State Forest. I have no background in mycology or Pacific Northwest forests, so this was a fun and unique project for me to complete. The question I'm attempting to answer is where to look for Pacific Goldens in Tillamook State Forest. The Cantharellus formosus is one of the most popular gourmet mushrooms, native to western North American rainforests, and have become Oregon's state mushroom. Golden chanterelles can grow up to 14 centimeters across with a dull orange to brown cap and stem. They grow by establishing a symbiotic relationship with host trees such as Douglas firs and western hemlocks. The fungus helps the root tips absorb water and nutrients in exchange for carbohydrates. And these mushrooms can be found starting in the summer and grow throughout the fall. Tillamook State Forest covers an area of about 364,000 acres. It's about 40 miles west of Portland and is managed by the Oregon Department of Forestry through 2 districts. The reason I chose Tillamook State Forest for my study area is because it's dominantly a coniferous forest and is a popular place for mushroom hunters. So to go about this question, I created a multi-criteria evaluation analysis to map the ideal conditions for chanterelle growth. The 4 criteria I based my analysis off of are host tree type, including Doug firs, western hemlocks, and less commonly Sitka spruce, alder, and beech. They're mostly above 1,200 feet up to 3,000 feet, but some studies have found them growing as low as 82 feet. And several studies have stated that the golden chanterelles favor second growth forests between 20 and 60 years. My last criteria I chose to include is canopy cover percent, for which 70 to 80% is favored. Chanterelles can also absorb heavy metals and other toxins from their surroundings, and because most of these mushrooms are harvested for consumption, it's cautioned to stay away from those growing near highways and mining areas. So I decided to make a quarter-mile buffer for major highways and a mile buffer around mines to exclude from the final map. I used about 7 data sets to build my analysis, including the Tillamook State Forest boundary from Oregon.gov Maps and Data page, a DEM downloaded from the Tillamook County Spatial Clearinghouse. I found forest type, age, and canopy cover data from 2 LEMMA data sets. LEMMA is a team comprised of employees from the USDA Forest Service, Pacific Northwest Research Center, and the Department of Forest Ecosystems and Society at Oregon State University. Their 30-meter resolution species map contained a ton of attribute fields, 2 of which were dominant forest type and canopy coverage percent. Their structure map raster contained a dominant age attribute for tracking down those second growth forests. And for the buffers, I used the Oregon Roads shapefile from PSU's Y drive, and then I also found a shapefile from usgs.gov for mines within the area. And then last I grabbed the 48, or the lower 48 shapefile from Lab 3 for an inset map of Oregon. My approach was to create a layer for each criterion with a common classification system from ideal to not ideal, and then combine the layers into one raster dataset based on their weighted importance. And I realized I kind of made this confusing by using the term better. In this project, better means better than good, not better than ideal. So sorry for making that kind of confusing. I started with the elevation layer by reprojecting this DEM to NAD83 statewide Lambert international feet and clipping it to the state forest boundary. I reclassified the elevation values into 4 classes. You could see 1,000 to 2,000 feet is ideal, 500 to 2,500 is better, and so on. And here's what the map looks like after symbolizing it by its rank. Next, I brought in the species map raster, reprojected and clipped it. This is what the raster classified by each forest type looks like before classifying it into 4 ranks. And here's the ranking system I used. The Doug firs and western hemlocks are ideal, and the betters and goods include the less favored species. Here's the result after I symbolized it by rank. You can see the eastern part of the state forest is almost all Doug firs and western hemlocks. And then there's a screenshot of the attribute table. Canopy cover was extracted from the same species map, but a different attribute field. Here's how I reclassified those values, 70 to 80 being ideal, 60 to 90 being better, and so on. And here's that canopy cover layer. With Lemma's structure map, I was able to extract the dominant age attribute values and then reclassify them like this, with 30 to 60 years being ideal, 20 to 80 being better, and so on. And here's my age map from that data set. So here are my 4 output rasters before putting them into the raster calculator. I started by giving them equal weights just to see how each raster overlays one another to get an output that looks like this. It looks pretty good. I ran it again, putting weights to each layer to get a different output that looks like this with a lot more ideal area. Before going any further, I wanted to get the buffer zones excluded from the map. So I brought in the roads, reprojected them, and selected the major highways to create a new feature class from. Then ran a buffer tool at a 1/4 mile. I did the same for the mines, but with the mile buffer. And then I merged the two and erased them from the state boundary. So I tried to create a model in ArcPro, but couldn't quite figure out how that function worked. I was able to come up with this, where you can see the layers and the tools that I used. So here's the equal weighted final output versus the weighted final output. And in my opinion, the equal weighted one seems more useful. It seems more useful in that there are less ideal areas, and it would be easier to pick out a place to head to go looking for mushrooms. One issue I came across after running the raster calculator was that an attribute table was no longer associated with the output. Perhaps I could have built a value attribute table to join to the final raster. I'm not sure. It'd be nice to figure that one out. And to keep building on this, I could add a soils layer with pH and soil chemistry, and I could also add the slope. So here are a few of the sources I used to gather information on golden chanterelles. And lastly, every article or paper I read stated the same thing about gathering mushrooms. If in doubt, throw it out. Thanks for your time.